Okay, hello everyone. Today we're going to solve quadratics by factoring. And we factored quite a bit already. All right, so a lot of this is going to be review. Okay. That's today's objective, to solve quadratic equations by factoring them. It's a good way to find out where it crosses the x-axis. Again, today's essential question: how does factoring help you solve quadratic equations? I think factoring is a good way to do it. All right, guys, remember, I'll back up here. The solution to a quadratic equation, it means a number of things. It's the value or values of x when y is 0. It's where the quadratic crosses or touches the x-axis. In fact, it's sometimes just called the zeros of the function. The values of x that make the function 0. When a solution to a quadratic, it's easy to find if it's written in factored form. All right, because factored form, if you set it equal to 0, it's 0 equals x minus r and x minus s. Therefore, s and r are both of the solutions. In order to make this true, x has to be equal to r, or x has to be equal to s, all right? Just a quick review, guys. Remember the axis of symmetry. It's always halfway in between the two x-intercepts. Or if it just touches the x-axis, it is at the intercept. All right, the x-coordinate of the vertex is the axis of symmetry. All right, the x-coordinate of the vertex, h, is the axis of symmetry. Now remember the zero product property? We talked about this. Again, when a times b equals 0, then either a or b must equal 0. And we use that when we factor a quadratic, because you get two linear factors. All right? When you set the function equal to 0, one or both of those factors have to equal 0. All right, so you set them each individually equal to 0 and solve them. That's how you get the solution. All right, as an example, guys, a lot of these quadratics you get, they're not going to be in standard form right away. All right, you need to put them in standard form first. Remember how to do that, the order of decreasing exponents, okay? If it's negative 20s on this other side, just bring it over to this side so we can set the quadratic, the entire function, equal to 0. All right, once you got that, factor it. All right, x squared plus 9x plus 20. Again, 4 times 5 is 20, and 4 plus 5 is 9. You set those equal to 0, you can see that x has to be either negative 4 or x has to be negative 5. Okay, we've talked about that before. Guys, this is a real-world example. Again, it's kind of like the picture with the frame. This is a museum vault. It has that outer shell, that big steel wall, that surrounds these big vaults, okay? They keep valuable things in there. Guys, they give you the area of the museum, the vault, and the ceiling, all right, with the outer wall. They give you the total area, all right? They want you to calculate the length of the outer wall, of the frame. We'll call it x. So the length times the width is the area, length times width, so 2x plus 20 and 2x plus 40. All right, that's the setup. It equals to the total area. Length times width equals the area. All right, y'all, multiply out 2x plus 20 and 2x plus 40. Multiply those out, all right, and then subtract the 1664 from both sides. All right, you need to set one side equal to 0. And once you have it equal to 0, guys, you can divide everything by 4. It doesn't affect the final answer. It doesn't affect the intercepts. All right, then it's a pretty easy factor, 6 and 36. All right. Guys, so we set these equal to 0. We get two answers. An answer could be 6, Or the answer could be negative 36. Guys, we know that the length of the wall, it can't be negative. Negative 36 can't be a solution in the real world. So we know the length of the wall, or the length of the frame around the outside, the width of the frame, is 6 feet. Okay? 6 is the answer there, the real world answer. All right, guys, that's it. Go ahead and complete the homework check. And again, we'll probably look at it in class tomorrow. All right, thanks.